Hey there, my name is Alex Bandar. I founded the Columbus Idea Foundry. We're a makerspace. We embrace the maker movement and provide a brick and mortar portal for anyone to engage with the exciting culture of 3D printing, crowdfunding, open source software, free information on the web. I give a presentation about this maybe 2 or 3 times a week to people who walk into the shop, but it's high time that I voice over some of these slides and push it to the web so that anyone who's interested in the democratization of design, the democratization of manufacturing, can see this stuff, learn about our mission without necessarily having to walk into the shop. So I hope you enjoy, hope it's helpful. If you have any questions or if anything piques your interest, please reach out at alex@columbusideafoundry.com. Thanks so much. When I deliver this presentation, I typically tailor it to the audience. I can give it one way if I'm speaking to artists, another way if I'm speaking to educators, yet another way if I'm speaking to technologists or entrepreneurs. But I think one blanket underlying phenomenon that applies to everyone is what I'm calling the democratization of design. And I think the moonshot goal of the democratization of design, or the maker movement in general, is how do we create 7 billion educated and empowered problem solvers? How do we empower all the potential innovators on our planet? And what I'd like to talk about today is a route that we're doing this locally, how we're empowering people in Columbus, Ohio, but also a moonshot goal about how I think this can apply globally. And we'll talk a bit about that too. This is our beautiful new-to-us facility. We moved here about 2 years ago after operating in a few different locations for 6 or 7 years. It's a 60,000 square foot warehouse. The first floor is all workshop tools from welding to 3D printing. The second floor is currently being renovated and will consist of offices for startups, event spaces, classroom spaces, a rooftop patio, and more. We're glad to be in the neighborhood of Franklinton. Here we can see the downtown area, downtown Columbus, Ohio. And up front here we see COSI, that's the Center of Science and Industry. It was the #1 family science center in America a few years ago. We're also just a couple of blocks from the 400 Westridge Arts community. This is 100 arts studios, 150 artists, a bar, an event space, a restaurant. There are a couple of other bars and restaurants within walking distance, including the Land Grant Brewing Company. The city of Columbus is building 700 apartments on this grassy lot here, just past the arts community. We're getting fiber optic cable at the end of this month, at the end of July 2016. So this means within a 2 or 3 block radius, you have science, you have art, we bring technology and entrepreneurship, we have walkable bars and restaurants, and a live-work neighborhood. I think this is an excellent recipe to produce the ecosystem necessary to foster creative and technology startups. Now, the inspiration behind the Columbus Idea Foundry was my own geeky self. As a young kid, I was always deeply inspired by science fiction movies and books in which robots would do our bidding, machines could make nearly anything we wanted, and software was more than just a fancy calculator, but could actually free us up for ideation and take some of the heavy lifting out of mental busy work. I think people are very bad calculators, but we're great thinkers. And I think we're seeing a trend towards software that is in fact doing this, helping us to make decisions. So I wanted to usher in this new era of technology, jetpacks and flying cars and all that. Went to college and studied a whole bunch of disciplines, from computer science to electrical engineering to mechanical engineering and more, and pretty quickly realized that you can design nearly anything. You can design a space elevator, you can design an airplane with a mile-wide wingspan, or a skyscraper with a 10-mile tall reach, but you can't necessarily build all of these things. And that's because, frankly, things break. The performance of engineering materials today can't necessarily support the superset of every idea that people can think of. So I thought, with the naivete of youth, it would be really exciting to create a new material. And I thought if you could create a new material, that would be like adding another color to the palette that all of the other engineering disciplines were painting with. If you made a more conductive copper, perhaps you can make a faster computer. If you make a stronger steel, maybe you can make that 10-mile-high skyscraper. If you made a more heat-resistant plastic, maybe you can even make automotive engines out of plastic. Think of the savings in weight, etc. So I went into materials science and engineering and became a computational metallurgist, where I wrote software for 10 years for a small startup that simulated manufacturing processes. Here we see a rivet being forged into an aerospace frame. And if you get the physics right, then you can predict the properties of parts made and hence the performance of those parts. So you can design an entire either unit process for manufacturing or an entire process chain, tweak each knob and dial until you get the property that you want and the component performance that you want, and then you build your factory. The exciting thing here too is that if you can virtualize all this, this manufacturing, then you can actually run experiments and try a handful of different types of variables. Maybe you have more or less teeth in a gear, maybe you have a thicker or thinner member here or there, and run designs of experiments to find the optimum processes or optimum variables to produce the performance that you want in a part. There are even more intelligent algorithms than doing a full design of experiments. There are algorithms that will sense the direction of the gradient of the response surface and say, you know what, this route really doesn't look like it's going to be fruitful. Let's do a very coarse analysis there. Or this area does seem to be providing some real results. Let's do a finer, more granular resolution in that area. And so you can be even more efficient than running a virtual design of experiments. And this isn't just an exercise in theory. This is a practical way to design things that more perfectly than humans might be able to. For example, if you want to make an automotive wheel rim, you want it to be strong so it resists denting when you hit that pothole. You also want it to be lightweight, so it's got better fuel efficiency, costs less in materials, etc. You can do this by either adding lots of thin spokes or a few fat spokes. I personally don't know what the right answer would be, but software and algorithms like this can help you get exactly the right design within the bounds of the scope of the process you've defined. It can find it more optimally than a human can. So did that for a number of years until my artist sister invited me to give a guest lecture to her art students. Coincidentally, while I was pursuing industrial metallurgy, she was pursuing artistic metalsmithing and became a professor of jewelry and sculpture up in Vermont. And I had a new PhD and a big ego, and I figured I'd teach her arts students something practical. So I put together a little presentation that defined the science behind heat and beat. Here we have a little picture of a Peruvian llama made hundreds of years ago with hammered bronze and soldered joints to make this statue. I thought that was great that people were actually doing things like that hundreds of years ago. But I hate to admit, just a few minutes into my presentation to my sister's art students, I realized that not only could I teach them nothing useful, but that they were all better welders, machinists, and blacksmiths than I. So if I had an idea, maybe I could write a computer program about it. If they had an idea, they just made the damn thing. And this did two things. It deeply humiliated me. It also made me very envious. I really wanted to be able to act on my ability to create things. But I didn't want to go back to college to learn how to weld or to learn 3D solid modeling for 3D printing. Thankfully, since I had graduated, YouTube had been invented. And effectively, this means, in a very general way, that information is free now. On YouTube and other informal or formal online learning methods, you can learn nearly anything. How to make a mobile app, how to make a table, how to make a website, how to make a business plan. There are formal colleges or online courses called MOOCs, Massive Open Online Courses, where hundreds of thousands of students can take the same class. And many people are doing this in the US, many more are doing this abroad in low infrastructure areas where colleges may not be as prevalent as they are here. Point being, people are using this information, and it's very exciting. Additionally, you don't need to pay thousands of dollars for professional design software to craft the digital images that you can think of. The open source software movement makes legally available, powerful, practical, free design tools available to anyone with a laptop and an internet connection, wherein you can design 2D images or vector images for laser cutting or CNC machining. You can design 3D shapes, you can design electric circuits, you can design whole assemblies. And speaking of those whole assemblies, you can also test virtually how those assemblies might work. This is a free program on the left called SketchUp. It was originally a Google product. Now it's a Trimble product. It's still free. And here's a free plugin called Sketchy Physics. This is a rigid body simulator where you can test how your design is going to function before you spend any time fabricating it or spending money on having it laser cut. There are also powerful, practical, free design tools that allow you to take advantage of the organic ability of 3D printers to print nearly anything. Sculptress is one such software where you can virtually carve a piece of clay. Wherever you see the mouse, you can drag or remove material, form it, add, change the color, etc. So as you can see, if you're a talented 10-year-old with a good eye and some patience, you can craft the digital file that you can then send to a 3D printer, or slice for a laser cutter to craft, or have a CNC machine carve out for you. Very exciting stuff. Here we have a few examples of a CNC machine carving out a small model car, and you can imagine maybe having designed that model car with that free virtual sculpting tool, and you can imagine having learned to use that tool with a free video on YouTube. Here we have an example of not just a single component, but a whole assembly of components being 3D printed simultaneously. This is about 90 ball bearings and 4 rings, all printed in situ. And here we have an example of a laser-cut wooden mechanical iris that one of our members made at the Idea Foundry. We add a servo motor, an Arduino electronics card, and a sensor to turn this into a teaching tool. When you wave your hand in front of the sensor, the servo motor spins the gear and opens the iris. So it's an exciting way to teach kids design, sensors, electronics, motors, fabrication, and more. The last phenomenon that I think brings into play the maker movement are innovations in financing, such as crowdfunding. Previously, if you had a good idea and you needed some capital to make it happen, you were one of many people competing for limited resources from a bank, from a lender, from an investor. Now, however, if you have a great idea, a camera on your cell phone, and a halfway decent sense of humor, you can make a 2 or 3 minute video pitching your idea to the world. And I've been heartened to realize that the world actually likes to reward good ideas. We've seen billions raised across the world through crowdfunding. We've been involved in hundreds of thousands of dollars at the Idea Foundry being raised for multiple Kickstarter projects. So this culture works. So to sum up again, I think you have free education, online learning. We have free, powerful design software, thanks to the open source movement. We have digital prototyping resources like 3D printers, laser cutters, and computer-controlled milling machines. This means you don't have to do what my sister did, which was to apprentice for years before you could make something that someone else will value. If you can craft the digital file, these machines will make retail quality products that you can then show to lenders or investors or produce as Kickstarter backer awards. And then, of course, you do have innovations in financing. I say that we reside at the center of these 4 phenomena, and that the remaining bottleneck to taking an idea out of your head and holding it in your hand is access to these tools and a supportive community of talented and friendly people to help you turn the crank on this whole process once. And that's the heart of the Idea Foundry. That's what we do. We provide access to tools. We teach theory-light, practice-heavy classes on all of them, and then we sell memberships so people can come in and have 24/7 access to their own workshop to create their own art projects, their own retail products, their own inventions, and more. Like I said, we've been doing this since 2008, for about 8 years, here in Columbus, Ohio. We've moved 3 times. We're now one of the largest makerspaces in the world. We're one of the most active by multiple metrics, and I'd like to show off a few of the ideas that people have realized at the Idea Foundry. We have a drones company, Infinite Impact, that does high-def photography and videography, and this really helps to market our culture also. As an engineer and a meritocrat, I thought a good idea sells itself. I deeply underestimated how important marketing is, and we're glad to do a lot of that now. Here we have a snapshot of some of our members. My friend Todd designed and built an electric motorcycle. We'll talk more about that. We have a design firm or two under our roof. We have a women's welding class that sells out the day we offer it. We have a Girl Scout troop that comes through and gets their product design merit badge on our laser cutter at the Idea Foundry. I'm really glad that the world is leveling up and creating things like product design merit badges for Girl Scouts. Make Magazine is the champion of this tech DIY culture. They coined the term maker movement about 10 years ago. They license maker fairs. Maybe you've seen these in New York, San Francisco, and elsewhere. And a few years ago, they ran a couple of competitions to see which city around the world can bring the most people under one roof to do things like 3D printing, electronics and programming, robotics. About 300 cities competed. I think that was probably half the global population of all the makerspaces in the world. You had cities from New York to San Francisco, London to Singapore. For giggles, the Idea Foundry tossed their hat in the ring, and nobody was more surprised than I was when Columbus, Ohio came in first in the world for 3D printing, first in the world for electronics and programming, first in the world for pyrotechnics, something we're awkwardly proud of, and second in the world for robotics. But I'd like to point out that the high school robotics team we sponsor, they came in first in the world in their own international competition, the First Tech Challenge, started by Dean Kamen. They beat out 3,000 other schools. The final was in Sydney, Australia. So I think this shows what happens when you give a talented community access to amazing tools and tell them to go play, to go be productive, to go make their ideas happen. A couple of those ideas follow right here. This is my friend Todd. He always wanted to design and build his own electric motorcycle, but like me, he grew up in a restaurant, and his background was woodworking. He was a carpentry framer for construction, but always enjoyed racing bikes and taught himself 2D and 3D design from resources on the web, learned all the electrics from forums and things like that, other enthusiasts and other professionals, welded up the frame in our shop, designed the chassis in 3D, and used one of our CNC machines, a 4-foot by 8-foot router table, to machine a foam mold that he used to pull carbon fiber composite over. So there's some real tech in here. He tested it at COSI. It ran great, and it actually spent a month in the Motorcycle Hall of Fame underneath a portrait of himself that had been painted by one of the artists at the local arts community. So really interesting collaboration between art and tech, and I think this is an example of a moonshot project achieved by someone who simply had passion and a great idea and access to tools to make that happen. Here we have a remarkable story. Battelle is the largest R&D nonprofit organization in the world. They're up the street from us in Columbus, and a few of their engineers had a side project. They wanted to apply their talent to compassionate technology. They wanted to see if they could help people solve their problems, and started a nonprofit R&D firm called One Lab. And somehow these farmers in Mali found them and explained that they'd been using an ancient mortar and pestle technique to separate the seed from chaff in their pearl millet. But unfortunately, that mortar and pestle technique crushes most of their grain, and they only get about a 30% yield once they've farmed it. So our friends used our workshop to build what's called a thresher. This is a way to use two rollers and to very well match the friction and pressure between rubber on one roller and expanded metal on the other to pull the chaff and to pull the seed out of their crop. They actually got a grant from the U.S. Department of Agriculture to go trial this thresher in Mali. Disassembled, it fits in a suitcase. And in fact, it tripled their crop yield of these farmers. So they were getting about 90% yield from it. This is a story where you have people with a problem, you have compassionate technologists who want to help that problem or help solve that problem. You have the shared resource model of a makerspace providing access to lots of tools and lowering the barrier to fabrication. And as a result, people's lives are materially better. Really exciting stuff. My friend Michael Cow, was a Honda engineer. He was responsible for the management of the design of the NSX supercar, but simultaneously he ran his business part-time, like I did with the Idea Foundry while I was still an engineer, and he built a company called IC3D that sells not just 3D fused deposition modeling printers, but also sells the filament. He ran a crowdfunding campaign to buy a used plastic extrusion press to produce filament for the 3D printing industry. Before, when these machines became grassroots, they were using weed whacker filament, which had about the right chemistry, about the right geometry, but none of the right tolerances for dimension or for humidity or porosity. So his crowdfunding campaign actually made a company that now produces the best rated filament in the industry. Here, our friends Brooks and Jake of Knockout Concepts designed and built a 3D scanner, and they used that scanner to to scan my noggin. I was wearing Google Glass at the time. That's this little protrusion here. That's not a tumor. And we used the IC3D machine in the previous slide to print busts of myself. So this is a cute little kitschy thing where you can make 3D business cards, as it were. But you can also do much less kitschy things too. Gavin Brooks, is a sculptor at the 400 West Ridge Arts Community. He's also a welding instructor and a sculpting instructor at the Idea Foundry. He was commissioned by a nonprofit called A Kid Again to build this memorial statue of a boy named Gabriel. Now, A Kid Again gives tickets to families with children undergoing cancer treatment so they can go to places like amusement parks or science museums or movie theaters and have some fun and some relief. And Gavin built this amazing statue, and then he asked if we at the Idea Foundry could 3D scan it so that he could 3D print smaller versions of it so that his intellectual property doesn't just live forever as a beautiful statue at the Kings Island Amusement Park in Ohio, but rather he can 3D print smaller versions to gift to the nonprofit so the nonprofit can give those away to high donors to incentivize them and to reward them for contributing to the mission. So his IP is actually now a sustainable form of revenue for the nonprofit. But we at the Idea Foundry, we're a social enterprise. We're not a nonprofit. So we have to cover our bills, pay the utilities and the mortgage. So when he asked, I said, well, what's your timeline and what's your budget? He said his timeline was just 2 days. It was shipping on Sunday, and he had no budget for the scanning. So I called the Knockout Concepts folks, the people who made that 3D scanner, called them late at night on Friday, and they showed up early Saturday morning, scanned Gavin's statue. We made these beautiful 3D meshes, which you can either texture map and visualize digitally, or actually create smaller maquette versions of. So here, I think this is another fantastic example of a collaboration between art and technology with a socially forward mission. Really love this. I'm also glad that we have not just 3D printers and laser cutters under our roof, but good old-fashioned blacksmithing. I'm going to turn my volume on here, and we'll see a trip hammer, which is an air compressor-powered blacksmith's arm, helping our blacksmith forge a piece of steel into a sword. And with this technique, we can do amazing things like Damascus metal to make really beautiful blades, do iron wrought work, teach the principles behind heat and beat, and a whole lot more. Speaking of marketing, when we had our ribbon cutting a couple of years ago, we invited the current mayor at the time, Mayor Michael Coleman, to cut our ribbon, but rather than the silk ribbon and oversized scissors, which is typical of most ribbon cuttings, we actually taught him how to plasma cut and had him torch through our metal ribbon. It's a lot of fun. This is, again, one of the aspects of marketing we're learning, how important that is to tell our story and evangelize this exciting culture. And because of this, TechCrunch gave us a bit of a bump out. Here we have a picture of what our second floor is going to look like very shortly, say December of 2016, in about 5 or 6 months. We're building a co-working space and a space with about 30 offices for startups. If you want to empower young people to create startups, you can't provide cubicle farms or an office park. You want a building with character. That's exposed brick, wooden beams, and that's exactly what our second floor looks like. And create a place people want to be. When they want to be there, they're going to interact with other people as well. You're going to have a great mix of artists and engineers, students and educators, marketing people, business development people, and as a result, you get this positive creative friction that produces something that's definitely greater than the sum of the parts. This is where we're heading in just a few short months. But I like to say we try to empower globally and inspire locally. And we're definitely hitting the mark when it comes to empowering locally. We have many hundred members and are making an impact in the Columbus technology and creative startup scene. But I think there are millions more who would like access to these kinds of tools, this kind of culture. And I think there's a route to making that happen. In India, the average disposable monthly income for a family is about $35. So my smartphone, or my laptop for that matter, is about $900. That price point is way too high for most people around the world. So a clever social entrepreneur, Suneet Sung Tuli, said, I think we need to make a phablet, that's a combination phone and tablet, at that $35 price point. If we can reach that, then we're going to see a flowering of this technology spread through people who really are yearning for this kind of access. He got very close. He got to $70 with a product called the Akash, or the Ubi Slate. But the state of India was so impressed with his product, they said, we're going to subsidize 50% of the cost of each of these for every student in India for the next 5 years. That's 200 million people. So here, I think we're seeing the burgeoning of an internet browsable device that can run simple software that's accessible to millions of people. But in many parts of the world, you still have infrastructure issues. You might not have electricity, frankly, to power it. One thing I really enjoy about the maker culture and the democratization of design or the democratization of manufacturing is that now you have markets of one, or markets of one village. You don't necessarily need to rely on a market pull for something to be available on the shelves at Target or by online sale at Amazon. Now, crowdfunding campaigns can bring into existence products that don't otherwise have a big market incentive, but do serve the need of people. Here we see an example of one of these products. This is a kick-started project called the Gravity Light. It's a high gear ratio electric motor with a hook that you hang it from the ceiling with, and a canvas sack that you can fill with something heavy like rocks or sand. As gravity pulls that bag down, it spins the motor, generates clean light and electricity. So people don't have to burn kerosene or wood or lumber, which have sustainability issues, which have health issues. Now you have clean, sustainable electricity. You can also imagine charging your device with this. So you have a browsable device, you have a way to power it, but you still need internet. And Google has this amazing program called Project Loon, where they plan to beam Wi-Fi to the planet with a fleet of hot air balloons. It might sound a little loony, but it's already trialing in New Zealand. So theoretically, you can have an Ubi Slate, which you charged with your gravity light, and you can be in a field with the sheep in New Zealand, browsing the web or downloading software or designing the next innovation. So I don't know necessarily if each of these will be the unit solution for that problem, but I think shortly there will be a very cheap browsable device that many people can have. There will be cheap, clean electricity. There will be cheap, widely available internet. And at that point, I think something special will happen. Right now, I feel that if you own something, whether it's a shirt or a laptop, it was designed by a tiny pie slice of the total global talent. If you add up all the engineers, industrial designers, software programmers, is it 50 million people? I'm not sure, but it's probably less than 1% of the planet. And those people generally are designing things that the market will sustain. But once you empower and educate the rest of the folks, I think we're seeing a potential pool of 7 billion innovators. If the maker culture continues to spread, and we're seeing libraries, schools, science and art museums, corporate innovation centers, private makerspaces like the Idea Foundry, we're seeing this culture spread. And we're even seeing fab labs in cargo containers or service bureaus where you don't actually need access to these tools. You can just email your file to a company like Shapeways, and they can mail you back your part. So I think we're seeing a hockey stick-like increase in the ability for people to take their ideas out of their head, hold them in their hands, and I think a really critical next step component is to teach those folks how to manufacture those prototype components. I think that's the next step, and I'm glad to be part of the conversation. If any of this resonated with you, if you're interested in continuing the conversation, please check out our website, columbusideafoundry.com. Check us out on Facebook or on Instagram, or check out my own blog, at Adventures of an Accidental Entrepreneur. It's also my name, Alexander Bandar, or feel free to email or call me. It's a really exciting time, and we're looking for more partners to make this happen. Thank you very much for listening.